Okay, ladies and gentlemen, this is going to be something a little bit new for you, okay? What we have here for you is a Module 1 multiple choice practice. And what you're going to see here is a lot of questions. Now, I need to fair warn you, so please hear me out. The information on this sheet, a lot of it is more difficult, okay? And you might not get it at first, and that's okay. So I'm going to try to explain as much stuff as I possibly can. Please hang with us. Please stay in there. Um, as you go through it, just make sure that you're writing down any questions you may have, and we will go over this as a class probably on Thursday or Friday. Okay? All right, here we go. Write the following values in ascending order. So for the first one, you're trying to put everything into decimals. Ascending means going up. So negative 2/3 is negative 0.66. Okay? 1.45 looks good. Square root of 5 is 2.23. Negative 2/4 is negative 0.5. 36 over 25. 1.44. And then 3 times root 8 minus 6. 2.45. Okay? So, when we go in ascending order, it's the smallest number first. Negative 0.66 is smaller than negative 0.5. So that goes first. Negative 2/3. Cross it off. Next is negative 2/4. Cross it off. Okay, look what we have left. 2.23, 1.44, 1.45, and 2.45. The smallest one is right here, 1.44. 36 over 25. Then we have 1.45. Then we have root 5. Lastly, 3 root 8 minus 6. Right? Ascending is rising up. Descending is from largest to smallest. Please just be aware of that. Okay. Number 2, if a is greater than 0, then the square root of 9a squared plus 16a squared equals what? Well, we can add these two together. So because they're both the exact same thing, 9 plus 16 gives me 25a squared. Keep it the same. It does not turn a to the 4th because you're not multiplying it. Now, when you square root this, the square root of 25 is 5. The square root of a squared, take your exponent, divide it by 2, just a. 5a. Alright? Number 3, the value of the square root of x squared minus 9 is real and irrational when x is equal to. So what we're looking at here is, if we can plug this in, real means that it exists. Okay, that means that you, for example, for the square root, you can't have a negative underneath there. So we're basically looking for something that's positive. Okay, and also irrational means something that is not a perfect square. So let's try this out. If I plug a 5 in here, 5 squared gives me 25 minus 9 is 16. The square root of 16 is 4. 4 is rational, so this does not work. Okay? If I plug a 0 in here, this is for the first one, here's the second one. If I plug a 0 in here, square root of 0 minus 9, the square root of negative 9 doesn't work. If you try putting that in your calculator, let me just show you this real quick. Square root negative 9, non-real answer. Okay, that's actually called imaginary. You don't need to know that now. You're going to learn that now in number 2. 4 squared is 16 minus 9. 16 minus 9 is 7. Square root of 7. Now, check this out. Square root of 7 gives me 2.64575131. That's an irrational number. Okay. Basically, the square root of any single number that's not that doesn't have a pattern, that's going to be, or doesn't have a perfect square, it's going to be irrational. Now, if I put 3 in there, 3 squared minus 9 is 0. Square root of 0 is 0. Okay. Again, just some key vocab there. This one's a bit tricky, so bear with me. The expression square root of 215x should be further simplified for which value of x. Now, what you're doing here is you're trying all these out, meaning put 118 in for x, put 35 in for x. Well, let's take a look. 215 times 118, 25, 370. Same thing here, 215 times 35, 75, 25. Okay. 215 times 38. 215 times 33. Okay. You're looking to see which of these numbers can be simplified down as far as perfect squares go. I'll give you a big hint. We're dealing with large numbers. Here are your perfect squares. 1, 4, 9, 16, 25, 36, so on, so on. For numbers this large, you're looking at either 25 or 100. Did we eventually get down to 100? Do you think 25 or 100 can go in any of these three numbers? Hopefully this one sticks out to you because it ends in 25. Any number that ends in 25 can be broken down. Okay, as far as square roots go. They love throwing ones like that at you. Okay, cool. Again, please don't get nervous if some of these problems are a little bit more complex. All right, we're going to slowly work through this. Suppose Jimmy simplified 6 squared of 425 with the following steps. One of the steps is incorrect. So let's see what he did here. 6 root 425. He broke it up with a plus sign. 400 plus 25. Square root of 400 is 20. Square root of 25 is 5. 20 plus 5 is 25. Multiply it. There you go. Identify and rewrite the incorrect step so it's correct. When you break up square roots, you can only break them up with multiplication. So over here, this should become root 25 times 17. Root 17. This now becomes 5. 6 times 5 is 30. There we go. Okay. So here's my correct work. Using the correct step from part A, simplify down. Okay, we just did that, so we're already good there too. Okay, but you always break down square roots with multiplication, not addition. Alright? Looking good. Down here. Find the GCF. Now, GCF is when we go low. Okay? So, what number goes into 10 and 5? That's going to be 5. And as far as x and x squared goes, which one's lower, x or x squared? Just your x. Let me show you guys something real quick. If I hit math, go to the right one, okay, you see number up there. I can scroll down. There's GCD. If you would like, you may do this. You can type in 10, 5 and hit enter. That gives you your GCF of 5. Now, to show you guys the next one, you cannot put 3 numbers in this calculator. 8, 12, 36. It won't do it. So you have to do 2 at a time. So if you would like to, I can do 8 and 12 first, and I'm going to get the GCF between the two of them, 4. Then, if you want, you could take that answer, 4, 36, and you'll find out your GCF is 4. If you would like to do that, by all means, your call. Everyone's in their own individual. Okay, as far as low goes, x cubed, x squared. The lowest is x. Nothing, y cubed, y. The lowest is nothing. Boom. 76 and 4, looking at my GCF here, can 4 go into 76? It can, so our GCF is 4 here, which is fine. X to the 9th, x to the 7th, x to the 7th is low, h and h, h. Okay, cool. Now LCM's a little different. We're going high on this one, okay? We're going high, go high. Okay, for this one, I even use this every now and then. Again, you hit math, number, scroll down, LCM, 450, 3000. This will not do variables. It only does numbers. 9,000. It's over 9,000. Okay, so then go high with your variables. X squared, x to the 4th. The high is x to the 4th. Y the 5th, y the 3rd. Y the 5th is higher. Okay? Looking good so far. Alright, for 30, 20, and 15, let's check this out. 30, 20, that's 60. I'm going to do it again. 60 and 15. 60. Okay? A cubed, nothing. The high is a cubed. If you're going high, you count it. B, nothing. B to the fourth. The high is b to the fourth. Okay. Alright. 40xy, 32x squared y. Again, I tend to just use the calculator a lot for LCM because it's just easier. You do start to get to higher numbers. 32, 160. Guys, if you need help with this calculator, please let us know. We can show you how to hit the math button, and then I'm going over and so on. X squared, the high is x squared. Y and y, the high is y. Alright? Wonderful. Okay. Go to our back page. See if we can get one more done before we take a little break. The manager at Frank's Snack Shack buys hot dogs in packages of 30. He buys hot dog buns in packages of 24. Unfortunately, he cannot buy part of the package. What's the least number of packages of each product he can buy to have an equal number of hot dogs and hot dog buns? So we're looking at LCM here. We're going high. The LCM between 24 and 30. Okay. So back to here again. LCM. Ooh, sorry. Math. Number. Scroll down. LCM 24, 30. 120. So 120 packages, or 120 of each. Now, you want to find out how many it is. Each package of hot dogs, 30. Take 120 divided by 30. Okay? So it's 4 packages of hot dogs. Then take 120 and divide it by 24. Okay? 5 packages of buns. Okay? There we go. All good. So it's good to get this number, but you have to take it one step further and you're in good shape. We actually have time for just one more quick one. Organizers for a high school graduation have set up chairs in 2 sections. They put 126 chairs for graduation in the front section, 588 chairs for guests in the back section. If all rows have the same number of chairs, what is the greatest number of chairs possible for each row? Greatest number of chairs possible. So we're looking at GCF, okay? So our GCF here, okay, is going to be... You're good. Okay, so GCF, we're going to take the GCF of 126 and 588. Okay, so I'm going to my calculator, math, 126, 588, so 42. Now here's a neat thing. It's actually, what's the greatest number of chairs possible for each row? That's it. Okay, like you don't have to do the extra work there because it already pans out for you. So, alright, we just finished the first part. I'm going to keep going with this, but we're going to take a little break. Alright, you can pause the video, you can take a, quick breather break, just kind of do your thing, and we're going to take a look at our next part and keep on rolling with this. Again, just a quick little word of encouragement. Guys, do not beat yourself up if your stuff is a little bit difficult. That's why we're getting practice with it, okay? Nobody was ever great the first time they picked anything up. Even Michael Jordan, the first time he picked up basketball, wasn't that good with it, okay? So, hang in there. We're going to do all we can to get you guys ready, all right? And just know that we really do believe in you, and also, very much important, good luck. We're all counting on you.